Hi, I'm an old guy and I do maths, and we're tasked with finding the distance from n to t in this illustration here. And this is a very rough impression of what you saw in the header. And this was part of a multi-part question in a geometry exam, and I thought I'd do various bits of it. So just bear with me. There is some extraneous material in here, but I'll do another couple of questions from the exam, and we'll use this illustration more fully. What we're looking for in this case is the distance from n to t. Now, this is all about being able to see and understand what it is that we're looking at. So what I've done is I've changed the perspective here, and I've simplified the drawing. And so now I'm looking down upon the drawing. And we have our distance 13 here, which corresponds to that, and our distance 10 here, which corresponds to that, and 65 degrees here. Now, don't be distracted by the fact that there's a sign here of a 90-degree angle. That refers to the angle between this, and the same is true here. This is not 90 degrees. We cannot assume that it is. It's possible, but very unlikely looking at the measurements here. And if it were 90 degrees, again, I'm not saying that this thing is anything near scale, but this would look quite a bit different. So we're not going to assume that. So what information do we have? Well, we have two sides and one angle, and that should bring to mind something. If it doesn't, you're going to learn something. It should bring to mind the cosine rule. Now, there are two rules: the sine rule and the cosine rule, and we use them when we are finding angles or lengths in non-right angle triangles. Now, if we knew a little bit more, we might be able to use the sine rule here. But we don't. We don't have either of these angles, which is what we'd really need to have the sine rule. So we're going to move down to the cosine rule, and what I'm going to do is I'm just going to relabel this triangle so that it conforms more to the cosine rule that you might be used to. So if this is angle A, this is little a, this is little b, and this is little c. Right, now let's go to work. Well, the rule, or the form of the rule that we're looking at in this case, is a squared is equal to b squared plus c squared minus 2bc times the cosine of a. Now, the naming conventions for a triangle, in case you don't quite understand what I did, if we call this angle A, then the side that's opposite it is little a. This would be angle B, little b, c, little c. Now, we have everything we need for this. We have B, we have C, we have A. We can find the cosine of that. So A squared is equal to 13 squared plus 10 squared, that's B squared plus C squared, minus 2 times 13 times 10 times the cosine of A, which I'll just get for you now. So the cosine of 65 degrees is 0.4226. We'll do it to 4 decimal places. Okay, well, so A squared is equal to, that's 169 plus 100, that's 269, minus 2 times 13 is 26, times 10 is 260, times 0.4226. Right, so 269 minus 260 times 0.4226 is equal to 159.124. I hope you can see that. Now, we need to find the square root of this number, and that will be this length here. So, square root of that is, I'll write it down here in big numbers, 12.6144. We don't know if this is meters or not. I can't remember the original drawing. We'll just leave it at that. The measurement is 12.6144. I hope that made sense. Thank you very much for watching. I hope you found it useful. If you did, please like and subscribe, and I'll see you next time. Bye.